So again, just starting with this one, casing, figure out the, you got two reactants, NO and O2, you had to figure out the order. So if you compare experiments 1 with experiment number 2, so you would notice that he's not doing anything to NO. He is only doubling the concentration of O2. So O2 की concentration if he doubles, the rate also doubles. तो कौन सा order हुआ?
Once.
ठीक है, so directly proportional. So that is order 1. ठीक है, so explanation में you'll just write if you compare experiments 1 and 2, O2 concentration doubles, rate doubles. So that means the order is 1. ठीक है, that's about it. और फिर इसी तरह अच्छा फिर इसी तरह you got इसको the other experiment. Which experiments would you compare for to figure out NO's order? That would be 2 and 3. You want to keep the other one constant, right? So you double this. So what happens to, तो ये double किया, the concentration was doubled. तो क्या हुआ है? By what factor? I think that's 4 times, right? But take this number divided by that one. So this is 4x. Is that clear? So that is 4 times. So that means कि order क्या होगा? That's going to be order. It's going to be order 2. Is that clear?
Yes, sir.
Based on that, now he's asking अगले part में ना calculate the rate in experiment number 4. So you figured out that this is order 2 and you figured out that this is order number 1, right? So ये जो experiment number 4 है, find out what the rate is for experiment number 4. How would you do that? Or directly, how would you figure out this one directly? But
Sir,
directly,
is it using the formula, sir?
so one way is you can make the rate equation. You know the order, right? So rate is basically NO के respect से it's order 2. And with respect to O2, it's order 1, right? But for that, you would have to calculate K. You would have to calculate the value of K. तो उसके लिए क्या करोगे? You'll input the concentration of NO in this. You'll input the concentration of O2 in it. किसी experiment की values जो है ना, you're going to plug it in. You'll find K. Once you find K, मतलब इस तरह कर लेते हैं ना कि मुझे बताओ K क्या होगा? I'm going to try and figure out. The rate is 4.08 times 10 to the power minus 3. NO concentration is 0.032 and it's squared, and O2 is 0.012. This is what is the value for K?
So 332.
332, right? So that means rate.
Yes, sir.
So that means rate is equal to 332 NO squared and O2 power 1. Okay, that's your rate equation. So I can now directly use experiment number 4 data and find out rate. Okay, so rate would be what? 332 times NO squared, so that's 0.096 squared. और ये दूसरा क्या है? 0.036 power 1. So find the value now.
So 1.10 times 10.81.
कितना? 1.1.
1.10 times 10 power negative 1.
ठीक है, 10 power negative 1, right? अच्छा, but you could have found it directly as well without, because this takes a lot longer time. Okay, you make the rate equation, okay, then you find the constant. Okay, what is the rate constant? And then you figure out, then you plug in the data and you find out what the rate is, okay? So it takes a much longer time. The shorter method is that you know the orders, right? You know कि ये क्या करते हैं. You double this, the rate will quadruple you. This is directly proportional, right? So what you can do as the shorter method is कि experiment 1 को पकड़ो and compare it with experiment number 4. What is happening to the concentration of O2? 0.012 था and now it's 0.036. 3 times हुआ है, right? So it's 3 times, right? तो इसका मतलब है कि, और order क्या है 1, तो इसका मतलब है the rate would be 3 times, right? तो इसका rate पकड़ो and multiply it by 3 times. ये वाला part clear है ना कि O2 concentration, I mean, you know the order, right? So you triple this, order 1 का मतलब है that will also get tripled, right? Is that clear?
Yes, sir.
अच्छा,
Yes.
लेकिन if you compare 1 and 4, NO is also changing. By what amount? It's also getting tripled, right? So the concentration of NO is being tripled. लेकिन वो, that is order 2. Order 2 means that if you triple this, that will become 9 times. तो इसका मतलब है NO की वजह से ना, it's going to be 9 times, right? So that means कि you're changing O2 3 times, the rate should increase 3 times, order 1. You're changing NO 3 times, but it is ordered 2, so that means वहां पे it's going to be 9 times, right? So total कितने times हो गया? That's, combine कर लो, that's going to be 27 times, right? मतलब पहले 3 times करो फिर 9 times करो, so that's basically 3 into 9 क्या हो गया? 27 times, right? तो इसको जरा multiply करो, 4.08 times 10 power minus 3 multiplied by 27. What do you get?
It's the same answer, sir. 1.10 times 10 to the power 91.
ठीक है, so you're going to get the same answer. So the point is that you can, I mean, there are multiple ways of actually solving the same thing, ठीक है? And तो मुझे ये थोड़ा सा manipulate करना आना चाहिए कि you can directly actually do that as well. Is that clear?
Yes, sir.
क्योंकि उसने ना rate equation actually बाद में मांगी है, and he's asking you to calculate के, so this question was actually, they were expecting you to actually solve it directly without the rate equation. The rate equation came in later, ठीक है? So later on they wanted the value of k and stuff like that, ठीक है? अच्छा, now this one, we'll skip the Boltzmann distribution. अच्छा, here's a reaction between a bromoalkane, R is the carbon chain. अच्छा, there's a bromoalkane, it's being hydrolyzed by NaOH. ये वो nucleophilic substitution है, ठीक है? So the Br is replaced, ठीक है? अगर नहीं याद organic, forget it, ठीक है? Let's say this is the reaction, ठीक है? There are two reactants, this one and this one. Bromoalkane and OH minus 1. What type of reaction is this? This is nucleophilic substitution, ठीक है? Skip to the rate part. उससे the concentration of bromoalkane was determined at regular time intervals as the reaction progressed. So he's following the concentration of bromoalkane. So you can see that कि bromoalkane की जो maximum concentration he used in the experiment was 0.01 mole per dm cube. वो जो दूसरा OH ions है ना, that's 0.1 mole per dm cube. तो that's in large excess. OH ions की जो quantity है ना, that's 10 times. मतलब ये कितना है? मैक्सिमम 0.01, फिर आहिस्ता आहिस्ता it starts decreasing as the reaction proceeds. जैसे जैसे वो time, I mean the time gets used up. अच्छा, so slowly the time, so the concentration decreases. So from a maximum of 0.01, NOH जो use किया ना, that's 10 times more. So that's in large excess. Large excess में I told you that when something is in large excess, so its concentration is considered to be constant throughout the reaction, because it's 10 times in excess. तो उसका मतलब है if a tiny amount gets used up, the quantity pretty much remains almost unchanged, or there's going to be negligible change in this value. तो अच्छा ये उसने ग्राफ बनाया हुआ है. By looking at the graph, can you tell me what order this is? इसका half life क्या है? Like 0.1, right? So 5. I remember draw the lines. ठीक है, obviously with a ruler, तो मेरे ख्याल से यहाँ पे कहीं आ रहा है. So क्या value? That's 117, I guess. ठीक है. फिर what's the second half life? अच्छा, second is यहाँ पे. What is that? That's like, तो बस इसको कर लेते हैं. This is 115, and that's like that's exactly 230. The constant half-life है, ठीक है. The first half-life is 115. The second half-life is also, it's also taking the same time. So constant half-life, what is the order if it's a constant half-life?
One, sir.
ठीक है, that's order 1. Constant half-life is order 1. अगर time double होता, that would be order 2. अच्छा, then he says that he repeats the experiment. ये वाला experiment जो था ना, that was done at 0.1 mole per dm cube concentration of NaOH, and now he repeats it where he uses the same experiment, but this time he uses NaOH, which has 1.5 times higher concentration, 0.15 mole per dm cube, and he gets this result. So I'm going to plot. Actually, I'm going to plot these results on this. उसने कहा plot these data on the axis and draw a line of best fit. ठीक है, so we're going to do that. So 0 पे it's 0.0. So the starting point is the same. 0 पे it's 0.010. 40 पे it's किधर है 40? तो 40 पे it's 0.07. This one. अच्छा, फिर 80 पे it's 0.049. 80 would be over here, 0.0. A 49 would be like very close to or almost equal to 5. अच्छा, फिर 120 पे it's 0.034. 120 is over here, 0.034 is approximately 35. अच्छा, फिर 160 पे it's 24. 160 is here. 2. बस वो approximately 25 है. और फिर इसी तरह it's 200 पे it's 17. Where would I put 17? 17 would be here, I guess. So anyway, so you got a line. Let's go. So we've got a or a line of best fit, ठीक है. Remember, it doesn't look to be a straight line, so it has to be. It's probably a curve. ऐसे बन गई sketch होगी, ठीक है, if you can see this on your screen. So so the first graph, ठीक है, the first one. The first वाला था ना ऊपर. That is where NaOH concentration was what, 0.1 mole per dm cube. और जो second line है, the second one, ठीक है, this one that's जो आगे चल रही है, ठीक है. That one is where NaOH concentration was what, 0.15 mole per dm. So the only thing he did in the two experiments was that उसने ना he increased the concentration of NaOH to 0.15 mole per dm cube. तो obviously reaction तेज हो गया, so the curve is much steeper, right? तो अच्छा, now इन दोनों experiments के comparison में ना RBR is no longer, RBR is constant now, ठीक है. RBR is not the issue. He's changing NaOH, so the reaction speeds up, right? So basically the second graph is there so that you can figure out the order with respect to NaOH. तो now if you want to figure out the order with respect to NOH, RBR का तो पता लग गया था by just looking at the half-life, like how RBR is decreasing, you were able to figure out the order with respect to RBR. मतलब ये बात clear है?
Yes.
अच्छा, so in the next part, he says use one of the graphs to confirm that the reaction वो तो हो गया था. Use the graph to calculate the order of the reaction with the NOH, show all your workings. So how would you do it with NOH? For NOH, you would have to figure out the rate of the reaction. कि पहले क्या rate था and what is the rate when NOH concentration was increased. Now, to figure out the rate, you would have to draw the gradient. And remember, you always compare the initial rate. You have to draw the gradient right at the beginning. So start के अंदर ना I'm going to sketch अब पता नहीं फ्री हैंड से ना बनता है कि नहीं बनता. तो I guess गलत ही लग रहा है वैसे, लेकिन so that's it. So right at the beginning over here, that's my gradient for the first one, and for the second one the gradient is वो कुछ इस तरह. ठीक है. So my two gradients, ये वाला थोड़ा सा मेरे ख्याल से इधर होना चाहिए था. इसको थोड़ा सा मैं even इस तरह, हाँ. अच्छा, anyway, so my two gradients of the two lines I've drawn. Let's calculate the gradient for this one. What is the gradient? It's y जो है, that's 0.01, or x-axis के way is it cutting? It's, I think that's approximately 175 minutes. ठीक है, तो x2 minus x1, that's triangle पूरा है. ठीक है, so that's this one. और इसका क्या होगा? It's going to be y2, the y-axis is 0.01, और नीचे जो bottom है, that's इसको भी थोड़ा सा 118 कर लेते हैं. ये दोनों की वैल्यूज मुझे बताओ कि what are the two values?
So the one on the left is 8.47 times 10 power negative 5.
And the one that's on the right?
5.71 times 10 power negative 5.
अच्छा, 10 per negative 5. ठीक है, so ये rate है. ठीक है, remember this gradient is the rate, right? तो ये इधर था, ये इधर था. तो by what factor did the rate increase? इसको इससे divide करो तो what do you get? I mean, initially the reaction was slow, then it became faster. So by what factor did it change?
One 1.48.
Approximately 1.5 times. ठीक है, approximately rate increased 1.5 times, right? इसको इससे डिवाइड किया तो we found out कि भाई the factor by which the rate is changing, that's 1.5 times. तो NaOH की concentration कितने times increase की थी? That was exactly 1.5 times as well. इसका मतलब है कौन सा order है कि NaOH की concentration you increase it 1.5 times, rate increased 1.5 times. तो क्या हो गया? So the order with respect to NaOH is 1.5 times. Is 1. Is that clear? Directly proportional है ना?
Yes.
तो ये clear है सारों को? तस्नीम, साले, is this clear? साथ clear है?
Yes, sir.
So
Yes, sir.
ठीक है. So remember this in this question, जो पहला part था ना RBR का, because he had sketched the whole I mean, how RBR changes throughout the reaction. So you could figure out the half-life and you can figure out the order with respect to RBR. For NaOH, he did a second experiment in which uski concentration thodi si he had increased it. So you were able, and he asked you to plot or sketch the second graph. So now you had two gradient. I mean, you could calculate two rates. ठीक है, पहला वाला rate था, and always remember initial rates are measured. 10 minute बाद you don't compare rates. ठीक है, you always compare the initial rate right at the beginning. So you drew a gradient, you drew a second gradient for the second one, and it came out to be कि भाई वो the difference is exactly 1.5 times. So which was directly proportional, which was order 1. तो यहाँ पे वो ही करोगे, it's going to be order 1. और बाकी वही है कि calculate the value for the rate constant. So with respect to both, I think the order is 1. वो RBR के respect से भी it's order 1, and OH के respect से भी, NOH के respect से भी it's also order 1. So you can now, what you can do is you can plug in the data for one experiment and find the value of K. क्योंकि rate तो आपने निकाल लिया ना, you just calculated rate, right? So for example, your rate was coming out to be 5.751 into 10 to the minus 5, right? तो इस वाले ग्राफ का जो और initial, right? So RBR concentration initially is what? 0.01. NOH concentration is 0.10. तो इन दोनों को जो initial concentrations हैं and the initial rate you calculate, plug it in and you'll find the value of K. तो K निकल आएगा, ठीक है? अच्छा, ये तो खैर वो इंथैल्पी वाला है. अच्छा, it's kind of exactly the same question. तो इधर क्या था कि अच्छा, there's this thing reacting with water and HCl, ठीक है? Initially it's 0.1 mole per dm cube. This thing I think वो कट हुआ है. This one is this one, ठीक है? So you've got point. So you've got 0.1 mole per dm cube, and he's asking, and he does a second experiment. Now HCl that is used is HCl that is used is 0.2 mole per dm cube. तो वो वही होगा कि वो कहेगा कि वो exactly same होगा. It's going to plot one, he's going to plot the other one, ठीक है? और फिर वो वही करेगा कि इधर क्या कर रहा है कि the concentration of HCl is doubled. So since he is doubling the concentration, तो वो, I mean, this reaction, the second reaction is going to be much steeper. ये 0 पे 0.2 है, इसका वो प्लॉट कर लेते हैं. 10 पे कितना है? That's 0.16. तो 10 यहाँ पे होगा, 0.16 कहाँ पे आ रहा है? 0.16. हाँ ठीक है. So I mean, it's a lot steeper, ठीक है? Start से ही ना, मतलब वहां से, अच्छा start से it's a lot steeper, ठीक है? फिर 25 पे it's 0.115. 25 would be, I guess यहाँ पे point कितना 115. तो 1 तो exactly I guess यहाँ पे होगा नहीं. 1 would be over here. तो 5 के ऊपर होगा. तो बस वो ग्राफ इज अ लॉट स्टीपर. तो वो what you'll do is और इसका ग्राफ कुछ इस तरह करके जा रहा होगा. you'll just plot two gradients. That will be the rate, initial rate, and you'll just compare. तो मुझे यहाँ से ही लग रहा है कि वो डबल हो रहा है. Steepness is doubling, right? So that means it's order 1. मतलब अगर वैसे देखे भी तुक्का लगाओ ना, तो you can see the gradient is doubling. So that means the rate is doubling. The concentration of HCl is doubled, rate doubles, hence it's order 1, directly proportional. ये क्लियर है क्वेश्चन ये वाला? मैंने पूरा सॉल्व नहीं करे, लेकिन इज दिस क्लियर?
Yes.
अच्छा, ये वाला है कि what is meant by the term order of reaction? So it's just the exponent of the concentration of a reactant in a rate equation. Construct a rate equation for this reaction. Now it's very easy because they've given you everything. The reaction is found to be first order with respect to this. तो सब कुछ तो दिया हुआ है. तो rate is what? It's equal to K. This is a ketone, so that's CH3CO. CH3, and it's क्या power है? It's order 1. And with respect to H+1, उसने कहा है कि H+1 के respect से it's also order 1. And it's 0 order with respect to I2. So that means you don't have to write I2. लिख दो तो कोई फर्क नहीं पड़ता, लेकिन it's when something has a power of 0, that means it's basically not there. ठीक है. As a paper, okay, the following sketches show 3 ways in which the concentration of reagents might vary during the reaction. Which of the above graphs correctly describes how the concentration of a reaction changes with time for propanone? Propanone order 1 है. Order 1 का ग्राफ किस तरह का होगा?
B.
A होगा. Order 1 का मतलब है when you have order 1, that means the half life is constant. Order 1 का मतलब है rate of the reaction depends on this thing. ठीक है. So जब उसकी concentration decreases, the reaction slows down. ठीक है. So you have a constant half life. ठीक है. It just keeps on slowing down. ठीक है. So it's going to be A. और यहाँ पे iodine it's 0 order. So how would the graph look like if you plot how iodine changes with time?
B.
हाँ, ये B होगा क्योंकि iodine के ऊपर डिपेंड ही नहीं कर रहा. So if iodine decreases, this rate will not decrease. So if iodine is decreasing, the reaction is not slowing down. It just decreases at a constant speed. ठीक है. Normally क्या होना चाहिए था? If iodine gets used up, the reaction should slow down. ठीक है. But 0 order में it does not slow down. It has no effect on the rate of the reaction. So 0 order is this one. So this is B.
Sir,
Yes.
could you explain graph C?
C is completely wrong. Because obviously when you have a reaction and when a reaction is going on, right? So what happens to the reactant? It gets used up, right? So it will never remain constant. It's always going to get used up. It's only going to remain constant in one instance, which is when you add it in large excess. ठीक है. लेकिन assuming you haven't added it in large excess, reactions always get used up. So they would always decrease. ठीक है. तो वो जो 3 graphs थे ना, they're going to look something like this. वो मैं फिर से दिखा देता हूँ किधर गया. अच्छा इधर गया. So we did 3 graphs, right? There was order 1. Reaction starts slowing down. Reactant will always get used up. Order 2 was it will slow down too much. The half-life doubles. TK, it just takes a longer and longer time because the rate depends too much on the reactant, right? And then you had order 0. Order 0 mein tha ke reactant gets used up, but it just gets used up at a constant speed. The speed of the reaction, the rate of the reaction remains constant. ठीक है. तो ये clear है कि you're never actually going to have C. Is that clear?
Yes, sir.
Yes.
वो जो C वाला ग्राफ था ना, वो था they're actually 2 types of graphs. ठीक है. One is you measure the concentration of a reactant with respect to time as the reaction proceeds. ठीक है. That's one type of graph. The other type of graph is you just basically plot the relationship. तो वो जो constant straight line आती है ना, when you just literally plot the relationship के भी एक ही concentration changes, the rate of the reaction should not change. ठीक है. So I mean they both represent exactly the same thing, but वो जो axes है ना, they're actually different. तो अगर यहाँ पे time है ना, तो time के साथ the concentration of the reactant should always decrease or go to 0. अच्छा अब है कि इस पे डायरेक्ट आ जाते हैं. Remember it's order 1. If the rate of the reaction depends on a particular reactant, ठीक है, तो वो reactant किस में होगा? Fast step or slow step? if a reactant is zero order, so that means that reactant is in the fast step. ठीक है, remember हमने पढ़ा था कि fast step को speed up करोगे ना, nothing would happen. Because well, if one step is taking 100 seconds and one step is taking 1 second, so if you increase the speed of the 1 second step, the overall speed of the reaction would kind of remain unchanged. Nothing would happen to it. So fast step जो होता है ना वो irrelevant होता है when it comes to speed of the reaction. ठीक है, it's always the slow step which determines the speed of the reaction. So since the rate depends on these two, they must be in the slow step. Is that clear?
Yes, sir.
और मैं यहाँ पे फिर से रिवाइज करा देता हूँ कि वो कहा था मैकेनिज्म्स नहीं, तो एंड पे पहुंच गए. हाँ, यहाँ पे हमने जितना भी प्रैक्टिस किया था, I told you that the rate will only depend on the any reactant present in the fast is always zero order. ठीक है, the fast step is irrelevant to increasing the speed of the reaction, and any reactant that's involved in the slow step is order 1, or I told you that the coefficient becomes the power. ठीक है, तो these must be in the slow step and this must be in the fast step. So based on this, so remember iodine को रखना है fast में and H and ketone should be in the slow step. So he's asking you to figure out which is the correct mechanism. So remember iodine has to be in the fast step. So I guess it's I think it's going to be B, right? That iodine is in the fast step, so rate does not depend on the fast step. It depends on the slow step. So H+1 and ketone must be order 1. ठीक है, is this clear? So the mechanism is B. But ये part clear
Sir,
है?
can you repeat that?
but ये वाला part clear है कि ये वाला part clear है कि anything that's in the slow step, rate depends on the slow step. Is that clear?
Yes, sir.
तो OH ion की अगर if you increase the concentration of OH ion, the overall speed of the reaction, I mean, pretty much nothing would happen to the overall speed of the reaction. Why? कि if you increase the OH ion concentration, तो ये 1 second वाला step speed up हो जाएगा. But that is not what will affect the overall speed of the reaction, क्योंकि वो 101 से कम होके it will still kind of remain approximately 101, right? तो OH का क्या है order? 0 है. मतलब it does not affect the rate of the reaction. Is that clear?
Yes, sir.
तो हाँ, इसकी concentration अगर बढ़ाओगे ना तो कौन सा step speed up कर जाएगा? The slow step would speed up. तो if the slow step speeds up, वो 100 seconds से 50 seconds पे आ जाता है, तो overall speed में there's a significant, so that means the rate depends on this thing, right? The rate depends on anything that's in the slow step. Any reactant that's involved in the slow step is what? It's order 1. ठीक है? और order 0 कौन है? Anything that's involved in the fast step. तो question में ना वो orders तो पहले ही given थे. But he had given you everything, all the information. He gave you the rate equation. तो इन दोनों के ऊपर the rate is dependent on this and this, not on iodine. इसका मतलब है these two are involved in the, I mean, they must be in the slow step. Whatever the mechanism is, let's assume we don't know what the mechanism is, but these must be in the slow step. ठीक है, ये clear है?
Yes, sir.
और it's not dependent on iodine, तो इसका मतलब है iodine must be in the fast step. ठीक है, तो हमें बस इतना पता है कि these two must be in the slow step, while iodine must be in the fast step. तो इसलिए मैं I had chosen B, कि iodine must be in the fast step and the other two must be in the slow step. Is that clear?
Yeah, I got it. Thank you.
क्योंकि इधर इस वाले में ऑर्डर्स क्या आएंगे? मैंने कहा था कि rate depends on the slow step, right? So rate depends on this step. So that means rate depends on iodine and H+1, while our equation tells us कि it does not depend on iodine. ठीक है, तो ये गलत हो जाएगा. अच्छा, इधर ये कि अच्छा इधर इधर ये होगा कि इस वाले में सी में why is C wrong? C would be wrong because slow step, right? Rate depends on the slow step. तो rate would depend on what? Rate would depend on iodine, जो कि गलत हो गया. हमने कहा था कि rate should not depend on iodine, right? अच्छा, it would depend on iodine's concentration and it would depend on the intermediate concentration. Intermediate को IM लिख देते हैं, ठीक है. और मैंने intermediate का क्या कहा था कि the intermediate itself is dependent on H+1 and ketone, right? So वो H+1 और वो जो कीटोन है ना उसको अगर वापस बीच में डाल दो, so that would mean that rate kind of indirectly depends on all of them, right? ये क्लियर है? ये वैसी प्रैक्टिस के लिए कह रहा हूँ कि rate depended on the slow step, so rate depended on iodine and the intermediate, तो मैंने वो लिखा. But I told you when we studied mechanism कि when I say that rate depends on the intermediate itself is formed by these two things, so it indirectly depends on these two things. उसका मतलब है rate indirectly depends on these two things. So is this clear, this one?
Yes, sir.
Yes, sir.
और फिर इसमें क्या होगा? Rate is dependent on the slow step, तो rate depends on this and this. वो iodine फिर से आ गया. अच्छा, explanation में खाली आपने लिखना है कि it's just all you have to write is कि the answer is B. Why? Because rate depends on the rate determining slow step. And ketone and H+1 are order 1, so they must be in the rate determining slow step. बस ये है. And rate does not depend on iodine, so it must be in the fast step. बस ये है. फिर ये आसान है कि you've already figured out अच्छा, you've already इसमें वो क्या कह रहा था? Find the value of K. तो he gave you the values. You already have the rate equation. कहाँ पे है rate equation? तो you can plug in the values and you can find the value of K. वो निकल आएगा, ठीक है. तो उसने concentration, rate, concentration of everything was given. And he's asking you to find the units of K as well. TK, that can also be done. What is the method by which you can measure the concentration of iodine? मतलब किसी भी experiment में how do you measure concentration of anything? Practicals में क्या करते थे?
Adding in excess.
नहीं मतलब NaOH दिया हुआ है. How would you measure the concentration of NaOH in the lab?
So is it finding the number of moles and the volume?
हाँ, तो उस process को क्या कहते थे? Titration था ना?
Titration.
हाँ, titration में कौन सा?
Digestion.
ठीक है. So you just titrate it with I mean you just do titration, right? Method पूछा, so he's not asking for the steps, he's just titration. That's one line answer, ठीक है. Units of K निकाल लो, तो units of K would be equation given है ना, you have to find the units of K. Rate is he's given you the units as well, ठीक है. जैसे यहाँ पे ना the rate calculated is mole per dm cube per second, right? वो जो concentration of propanone, iodine and H+1, that's mole per dm cube and mole per dm cube, ठीक है. तो I'm going to find the units of K. अच्छा, mole per dm cube को I'm going to take it as X. तो rate is mole per dm cube per second. Then you have K. Then you have propanone, that's mole per dm cube. Then you have H+1, that's also mole per dm cube. Iodine तो वैसे निकल के बीच में से, ठीक है. So ये x से cancel out हो गया. The other x goes to the other side, so that's x minus 1. So the units for K are mole per dm cube power minus 1. So that's mole minus 1 and dm3 and s minus 1. Clear है? Unit उसी तरह निकालना है. Kc, Kp, etc. You find units in the same way. You just simplify it. बस वो mole per dm cube को ना make sure you take it as x. वो इसलिए कि वो मोल पर डीएमक्यू के साथ ना वो चीजें कैंसिल आउट करना, इट काइंड ऑफ गेट्स कंफ्यूजिंग. सो मोल, तो मैंने उसको मोल पर डीएमक्यू पर सेकेंड, मोल पर डीएमक्यू और के, तो मैंने सिंप्लीफाई कर दिया. इज दिस क्लियर?
Sir, is it dm power of -3? Is it?
नहीं, x -1 है ना, तो दैट्स मोल पर डीएमक्यू पावर -1.
Okay. Sir.
तो वो मोल -1 हो जाता है, DM3 हो जाता है. अच्छा फिर तो इसका ये तो आसान है कि इफ यू कंपेयर एक्सपेरिमेंट्स 1 and 2, तो O2 is कितने टाइम्स है? दैट्स 1.5 times, right? This one, first two में. And what happens to the rate? That's also 3 divided by 2, that's 1.5 times, right? So there's 1.5 times increase, 1.5 times increase, so that's order 1, right? Clear है कि experiments 1 and 2, if you compare 1.5 times increase, 1.5 times increase. Is that clear?
Yes, sir.
और 2 और 3 को कंपेयर कर लो. 2 और 3 में this remains constant, so this is doubled, NO is doubled. तो वहां पे क्या हो गया? 4 times. 3 से 12, that's 4 times. Double करोगे, that's 4 times. So that's what, order 2. ठीक है. तो उससे क्या, write the rate equation. So just write it down. Okay, rate is equal to K NO squared, and O2 is power 1. ठीक है, क्लियर है?
Yes.
एंड फिर वो वैल्यू ऑफ के निकालो. सो यू जस्ट प्लग इन द डेटा के NO is 0.005, this is 0.005, rate is 0.02. उसको यहाँ पे plug in करो and you find the value of k. ठीक है. And you want to find the unit of k, तो you can just मतलब क्या unit, mole per dm cube NO, so that's mole per dm cube squared. उसको मैं x ले लेता हूँ. O2 is mole per dm cube, so that's x. K का मुझे I don't know. Rate is mole per dm cube per second, so that's x s minus 1. So EX cancel out. This x square goes to the other side, so that's x minus 2. So my unit for K is mole per dm cube power -2. So mole -2 dm6. S minus 1 is equal to K. ठीक है. तो ये K का unit भी आ गया, and you can find the value of K. And once you have the rate equation, you have the value of K as well. तो उससे क्या है कि rate निकालो. So NO and O2 concentration is given. So you're going to plug in the NO and O2 concentration here and here. K की value just found it out, तो plug in K, you'll find the value of rate. ठीक है, clear है?
Yes, sir.
Yes.
तो बस ठीक है, चलिए ये प्रैक्टिस करो. ठीक है, ये वर्कशीट होमवर्क है. ठीक है, मेक श्योर ट्राई एंड डू. कल फिर होपफुली विल स्टार्ट विद इक्विलिब्रियम अ लिटिल बिट. ठीक है, तो इसमें कोई क्वेश्चन नहीं था आज?
No, sir.
चलिए, ओके देन, टेक केयर एवरीवन.
Thank you, sir. Hafiz.
हाफिज.
Love.
Sir,
जी
do you have an answer key to these questions?
हाँ,
Like the
एक
mark scheme?
वो मैं भेज, एक से मैं दिखा देता हूँ. मैंने भेजी, सॉल्व है मेरे पास. इट्स दिस वन, राइट? ये कह रहा ना. और हाँ, ये पड़ी भी है. इट्स सॉल्व. ठीक है, तो ये मैं भेज देता हूँ. हाँ, इस पे सारे सॉल्व हुए मैं.
Okay, thank you.
चल ठीक है, ओके, हाफिज.
Hafiz.